What if I told you that your car already has more power than you're currently experiencing, but it's being intentionally limited? Not because something is broken, not because your engine is weak, and not because your car is old, but because of how it has been designed to operate. This might sound surprising at first, but modern vehicles are not simply mechanical machines anymore. They are controlled systems that constantly adjust themselves based on how they are used. The most interesting part is that unlocking a more responsive driving experience doesn't always require expensive upgrades or tools. In many cases, it comes down to a setting that already exists inside your car, something that costs absolutely nothing to access, yet remains unknown to most drivers. The reason this goes unnoticed is not because it is complicated, but because it is hidden beneath layers of system behavior that most people never think about. When people experience a drop in performance or slower response, they often assume something is wrong with the engine or fuel system. However, what's actually happening in many cases is far more subtle. Your car is adapting to you. Every time you drive calmly, accelerate gently, or prioritize smoothness over speed, your vehicle begins to learn that pattern. Over time, it adjusts how it delivers power so that everything feels more controlled, more efficient, and less aggressive. While this improves comfort and fuel economy, it can also make your car feel slower and less responsive than it actually is. This is why two identical cars, with the same engine and same specifications, can feel completely different depending on how they have been driven. One may feel sharp and responsive, while the other feels delayed and sluggish. This difference is not always mechanical. It often comes from the system inside the car that controls how power is delivered. And the system is not something most drivers ever interact with directly. It operates quietly in the background, making adjustments based on patterns it observes over time. At the center of all this is something called the Engine Control Unit, or ECU. This is essentially the brain of your car. It manages critical functions such as fuel delivery, throttle response, ignition timing, and even how quickly your car reacts when you press the accelerator. But what makes the ECU particularly important is that it is adaptive. It does not simply follow fixed instructions. Instead, it learns from your driving behavior and modifies how the car responds accordingly. If you tend to drive conservatively, the ECU gradually adjusts the system to favor smoother acceleration and reduced power spikes. On the other hand, if you drive more aggressively, it can shift toward quicker response and sharper performance. Manufacturers design cars this way for several important reasons. First, there are strict fuel economy standards that vehicles must meet, and smoother, less aggressive throttle response helps improve efficiency. Second, emissions regulations require engines to operate within certain limits, which also influences how power is delivered. Third, manufacturers prioritize long-term reliability and comfort for the average driver, which means reducing stress on engine components and avoiding sudden, harsh acceleration. Finally, there's also a business aspect involved, as companies often use software to create different performance characteristics across various models and trim levels, even when the underlying hardware is very similar. As a result, the driving experience you feel is not always the full potential of your engine. Instead, it is a controlled version of that potential, carefully balanced to meet multiple requirements. Over time, as your driving habits reinforce certain patterns, and this controlled behavior can become even more pronounced, the car becomes smoother, but also less responsive. It becomes efficient, but not necessarily engaging. And this is where most drivers begin to feel that their car has lost power, even though the engine itself is functioning exactly as it should. This brings us to the key idea behind the hidden setting. It is not about increasing horsepower or modifying engine components. Instead, it is about influencing how the system interprets your inputs and how quickly it responds to them. By understanding how this adaptive system works, it becomes possible to reset or adjust it in a way that restores a more direct and responsive driving feel. This does not change the physical capability of the engine, but it changes how that capability is delivered, which can make a noticeable difference in everyday driving. Once you become aware of this, you start to see your car differently. What seemed like a loss of performance may actually be a result of adaptation. What felt like sluggish acceleration may simply be delayed response programmed for efficiency. And more importantly, you begin to realize that some of these limitations are not permanent. They are part of a system that can be influenced, adjusted, and in some cases, reset. So the real question is not whether your car has more potential, but how that potential is being managed. What exactly is this hidden setting, and how can it be accessed safely without causing any issues? In the next part, we'll break down what is actually happening behind the scenes and explore the specific factors that control how your car responds, so you can understand exactly where this extra responsiveness comes from and how to bring it back. To understand what this hidden setting really is, you first need to look at how modern cars respond when you press the accelerator. Most drivers assume that when they press the pedal, the engine instantly gives exactly the amount of power they are asking for. But in reality, that's not how most modern vehicles work. Instead of a direct mechanical connection, today's cars use an electronic system commonly known as drive-by-wire, where your pedal input is interpreted by the ECU and then translated into throttle movement. This means your foot is not directly controlling the engine. The system is deciding how much response to give based on multiple factors. One of the most important of these factors is something called throttle response learning. Over time, your car observes how you drive and begins to adapt accordingly. If you tend to accelerate gently, maintain steady speeds, and avoid sudden inputs, the system gradually adjusts itself to favor smoother and more gradual power delivery. This makes the car feel comfortable and efficient, but it can also make acceleration feel delayed or less responsive. In simple terms, your car starts to expect gentle driving, so it reduces how aggressively it responds, even when you press the pedal more firmly. This is why many drivers experience a situation where they press the accelerator and feel like the car hesitates for a moment before responding. It's not because the engine lacks power, but because the system has been conditioned to deliver that power more slowly. Over time, this adaptation can become so strong that the car feels noticeably less responsive than it originally did when it was new. And this is where the key realization comes in. If your driving habits have been calm and consistent, your car may actually be limiting its own responsiveness based on what it has learned from you. Now, this doesn't mean the car is malfunctioning. In fact, it is doing exactly what it was designed to do. Manufacturers build these adaptive systems to improve fuel efficiency, reduce wear on engine components, and create a smoother driving experience for the majority of users. However, the downside is that the system can sometimes go too far in that direction, especially if it rarely sees aggressive inputs. When that happens, the car begins to feel less lively, even though its actual performance capability has not changed. Another important factor that influences this behavior is the drive mode system found in many modern vehicles. Most cars today come with different modes, such as Eco, Normal, and Sport. These modes directly affect how sensitive the throttle is and how quickly the engine responds. In Eco mode, the system intentionally reduces throttle sensitivity to prioritize fuel savings, which can make the car feel slower and less responsive. In Normal mode, the balance is more neutral, but it can still lean towards smoothness rather than sharpness. In Sport mode, however, the system becomes more aggressive, increasing throttle responsiveness and making the car feel quicker and more reactive. What many drivers don't realize is that staying in Eco mode for long periods can reinforce the adaptive behavior of the ECU, making the car even more conservative over time. Even when switching back to Normal mode, the system may still carry over some of those learned patterns, which can continue to affect how the car responds. This is why simply changing modes doesn't always instantly restore the original driving feel. The system itself has adapted, and those adaptations don't disappear immediately. A third element that plays a role in this hidden setting is throttle or pedal calibration. In some vehicles, the system needs to understand the full range of the accelerator pedal, from completely unpressed to fully pressed. Over time, slight inconsistencies in how the pedal is used can affect how the system interprets those inputs. This is where recalibration comes in. Certain cars allow the throttle system to be reset or relearned, often through a simple ignition sequence. While the exact method varies depending on the make and model, the underlying idea is the same. The system is being reminded of its full range and reset to a more neutral state. When this recalibration happens, the difference can be noticeable. The car may respond more directly to pedal input, with less delay and a more immediate sense of acceleration. Again, this is not because the engine has gained new power, but because the system is no longer limiting how quickly that power is delivered. It's essentially restoring the connection between your input and the car's response, making everything feel sharper and more predictable. And this is where things start to get really interesting. Because when you combine these three elements, adaptive throttle learning, drive mode behavior, and pedal calibration, you begin to see how much influence the system has over your driving experience. The car you feel every day is not just defined by its engine or hardware, but by how the software inside it has been shaped over time. That means small changes in how the system is configured or reset can have a surprisingly large impact on how the car behaves. Understanding this changes the way you look at performance. It's no longer just about horsepower numbers or mechanical upgrades. It's about how efficiently and directly that power is delivered to you as the driver. And in many cases, improving that delivery doesn't require expensive modifications. It simply requires resetting or adjusting the system so that it responds the way it was originally designed to. And this is exactly why this hidden setting matters. Because when the system is reset or recalibrated correctly, the car can feel more alive, more responsive, and more connected to your input. It doesn't become a different car, but it becomes a better version of the one you already have. Before you try anything, it's important to understand one thing clearly. Not every car uses the exact same system, and not every manufacturer allows the same type of reset or recalibration. That's why the first step is always to check your vehicle's manual or manufacturer guidelines. These methods are generally safe and widely used across many modern vehicles, but you should never force a process that doesn't apply to your specific model. The goal here is not to modify your car, but to help the system relearn and respond more accurately. So always approach this carefully and responsibly. Now, the first method is the most commonly discussed and one of the simplest ways to allow the system to relearn throttle behavior. This is often referred to as a throttle reset or pedal relearning process. In many cars, the ECU stores information about how the accelerator pedal is used over time. By resetting this learned behavior, you can sometimes restore a more direct response. The general version of this process begins by turning the ignition to the on position without starting the engine. Once the system is powered, you slowly press the accelerator pedal all the way down to the floor in a smooth and controlled motion. After reaching full press, you hold the pedal in that position for about 10 seconds, allowing the system to recognize the maximum input range. Then, you slowly release the pedal back to its original position, again keeping the motion smooth rather than abrupt. After that, you turn the ignition off completely and wait for about 1 to 2 minutes before starting the car normally. The idea behind this process is not to unlock hidden horsepower, but to help the ECU recalibrate its understanding of your pedal inputs. Over time, if your driving style has been very gentle, the system may not fully register the entire range of motion as frequently. This reset helps reestablish a more accurate baseline, which can result in quicker and more consistent throttle response. It's a subtle change, but for many drivers, it's enough to make the car feel noticeably more responsive in everyday driving. The second method focuses on how you actually drive the car after resetting or even without doing a formal reset. This involves using the different drive modes available in your vehicle, specifically moving between eco, normal, and sport modes in a structured way. Instead of staying in one mode all the time, you intentionally cycle through these modes during a drive. For example, you can begin by driving in eco mode for about 10 to 15 minutes, maintaining smooth and steady input. Then switch to normal mode for another 10 to 15 minutes, gradually introducing more varied acceleration. Finally, move into sport mode and drive more assertively, using stronger throttle input and allowing the system to experience a wider range of driving behavior. This method works because the ECU is constantly learning and adapting. By exposing it to a broader range of inputs, you encourage it to adjust toward a more balanced or even slightly more aggressive response pattern. Many drivers who only use eco mode unintentionally train their cars to become overly conservative. By cycling through modes and driving more dynamically, you help the system recalibrate its expectations, which can improve responsiveness over time without needing any tools or adjustments. The third method is more advanced and should only be used if you are comfortable with basic vehicle maintenance. This involves temporarily disconnecting the car battery to reset the ECU's stored memory. When the battery is disconnected for several minutes, the system loses its learned adaptations and returns to its default state. After reconnecting the battery and starting the car, the ECU begins learning again from scratch. This can restore the original responsiveness that the car had before it adapted to long-term driving habits. However, this method comes with important considerations. Disconnecting the battery may reset other systems in the car, including the clock, radio settings, and in some cases, certain convenience features. Additionally, some modern vehicles have more complex systems that may require reinitialization after a battery reset, so it's important to understand your specific vehicle before attempting this. This is why it is often recommended as an optional method rather than the first approach. After applying one or more of these methods, many drivers report a noticeable difference in how their car responds. Acceleration can feel sharper, the delay between pressing the pedal and receiving power can be reduced, and the overall driving experience may feel smoother and more connected. It's important to keep expectations realistic, though. This process does not increase the engine's maximum power output. Instead, it improves how that power is delivered, making the car feel more responsive and easier to control. But here's the part most people don't realize. These changes are not permanent unless your driving habits also change. If you return to very gentle, consistent driving for long periods, the system may gradually adapt again, reducing responsiveness over time. This means that maintaining a balanced driving style, occasionally using more varied throttle input, can help preserve the improved feel you've achieved. And this is where everything starts to connect. You begin to see that your car's behavior is not fixed, but constantly evolving based on how you interact with it. The more you understand that relationship, the more control you have over how your car performs in everyday situations. At this point, the most important thing to understand is why all of this actually works. Once you see the system clearly, everything you've experienced starts to make sense. Modern vehicles are not controlled purely by mechanical systems anymore. At the center of everything is the ECU, or engine control unit, which acts as the brain of the car. But unlike older systems, this is not a fixed controller. It is adaptive, meaning it constantly observes how the car is being driven and makes small adjustments over time. These adjustments influence several key areas, including throttle sensitivity, shift timing in automatic transmissions, and even slight variations in fuel delivery. The purpose of these adjustments is to create a driving experience that matches the habits of the driver while also meeting efficiency and reliability goals. When you drive gently over long periods, the ECU gradually shifts towards smoother throttle response and less aggressive power delivery. This makes the car feel more refined, but it can also create a sense of delay when you suddenly ask for more acceleration. On the other hand, when the system is exposed to more varied or assertive inputs, it can adapt in the opposite direction, becoming quicker and more responsive. This is not about changing the engine itself, but about changing how the system interprets your inputs and how quickly it responds to them. This leads to one of the most important ideas in this entire discussion. You are not adding power to your car. You are unlocking responsiveness that was already there. The engine has always had the ability to deliver that performance, but the system controlling it may have been holding it back to prioritize other factors. By resetting or influencing that system, you are simply allowing it to return to a more neutral or responsive state. This distinction is critical because it keeps expectations realistic and avoids the misconception that a simple reset can dramatically increase horsepower. Now, it's also important to understand why manufacturers design cars this way in the first place. The first reason is fuel economy. Governments around the world impose strict efficiency standards, and smoother throttle response helps reduce fuel consumption during everyday driving. The second reason is emissions control. Engines must operate within specific limits to meet environmental regulations, and controlled power delivery plays a role in maintaining those limits. The third reason is comfort. Most drivers prefer a smooth, predictable driving experience rather than a highly sensitive throttle that reacts aggressively to every small input. Finally, there's the aspect of long-term reliability. By reducing sudden stress on engine components, manufacturers can help ensure that vehicles last longer and require fewer repairs over time. Once you understand these factors, it becomes clear that the system is not designed to limit you unfairly, but to create a balanced experience for the average driver. However, that balance does not always match what every driver wants. Some people prefer a more responsive feel, and that is where understanding the system gives you an advantage. Instead of assuming something is wrong with your car, you begin to recognize that it may simply be operating in a mode that prioritizes efficiency over responsiveness. At the same time, it's important to set realistic expectations. This process will not give you a dramatic increase in engine output, and it will not transform your car into something completely different. What it can do is improve how the car feels when you drive it. You may notice that acceleration becomes more immediate, that the delay between pressing the pedal and receiving power is reduced, and that the overall driving experience feels more connected. These changes may seem small on paper, but in real-world driving, they can make a significant difference in how enjoyable and responsive the car feels. This is also where many people misunderstand the concept. They expect a massive performance boost, and when that doesn't happen, they assume the method doesn't work. But the real benefit is not in raw power. It is in control and responsiveness. When your car reacts more quickly and predictably to your inputs, it becomes easier to drive, more engaging, and in many cases, more efficient because you can manage acceleration more precisely. So the next time your car feels slow or unresponsive, don't immediately assume that something is broken or that your engine has lost its capability. In many cases, it may simply be adapting to how you've been driving, gradually shifting toward a smoother but less responsive state. And once you understand that, you realize that you have more influence over your car's behavior than you might have thought. It might just be holding back, waiting for you to change how you interact with it. And that realization changes everything, because it means the solution is not always mechanical. Sometimes it's about understanding the system and working with it rather than against it. Once you start paying attention to how your car responds, you begin to notice patterns, small changes, and hidden behaviors that were always there but never obvious. And once you reach that point, you don't just drive your car anymore. You understand it. You recognize what it's doing, why it's doing it, and how to influence it. And that's where the real advantage comes in, because the more you understand these hidden systems, the more control you have over your driving experience. And this is just one example. There are many other hidden behaviors and systems inside modern vehicles that most drivers never notice. But once you start looking for them, you'll realize that your car has been quietly communicating with you all along.